Today's lesson is one that many students struggle with, not because it's difficult, but because they miss one or two simple steps. By the end of this lesson, you'll know exactly how to solve linear inequalities, graph the answers correctly, and write them in interval notation. This skill will be useful for school exams, external examinations, and standardized tests. Example 1, 2x minus 3 all over 5 greater than 1. The first thing we need to do is remove the denominator so that the inequality becomes linear. To do that, we multiply both sides by the LCM of the denominators. Since the only denominator here is 5, the LCM is 5. So we have 5 times 2x minus 3 all over 5 greater than 5 times 1. The 5's on the left-hand side cancel out, leaving us with 2x minus 3 greater than 5. Now let's solve for x. So we add 3 to both sides. To eliminate 3 from the left-hand side, because minus 3 plus 3 is 0. So this becomes 2x greater than 8. Next, divide both sides by 2, which is the coefficient of x. And the answer is x greater than 4. Let's represent it on the number line. Since 4 is not included, we'll draw an open circle at 4, then draw the arrow pointing to the right, because we're looking for values greater than 4. And in interval notation, since 4 is not included, we use a parenthesis, so the interval notation is 4, positive infinity. If you haven't watched my lessons on graphing inequalities or interval notation, I've linked them in the description. They'll help you understand this part even better. Example 2, 3x minus 5 less than or equal to 2x plus 7. This inequality is already linear, so we don't need to remove any denominator. We go straight to collecting like terms, subtract 2x from both sides. (3x minus 2x is x. So we have x minus 5 less than or equal to, here we have just 7, because 2x minus 2x is 0. We write 7. Now, add 5 to both sides. Notice that, to eliminate a term, we use the opposite of that term. And whatever you do on one side, you do the same on the other side. So here, minus 5 plus 5 is 0, we have just x, less than or equal to 7 plus 5 is 12, our answer is x, less than or equal to 12. Let's graph the solution. Because 12 is included, we'll draw a closed circle at 12. Since the solution is less than or equal to 12, the arrow points to the left. This means the value starts from 12, down to minus infinity. Let's write the answer in interval notation. Remember, we always write the smallest value first, which is minus infinity, and because it's continuous we use a parenthesis, put a comma, and 12 with a square bracket, since 12 is included. Example 3. 2x plus 7 less than 15. This inequality is already linear, so we can go straight to solving it. Our goal is to get x on its own. To do that, we remove other terms that are with x using their opposite signs, and whatever you do on one side, do the same to the other side, to balance the solving. So here we subtract 7 from both sides. Plus 7 minus 7 is 0. And we have 2x. Bring down the less than. 15 minus 7 is 8. Next we divide both sides by 2, since 2 is the coefficient of x. That gives us x less than 4. And that's our answer. To represent it on the number line. Since 4 is not included, we'll draw an open circle at 4, and draw the arrow towards the left, because we're looking for values less than 4. Now for the interval notation. The solution starts from -infinity and ends at 4, but 4 isn't included. So we use parentheses on both sides. Starting with -infinity, comma and 4. Before we move to the next example, I want you to notice something. Every example we've solved so far follows the same idea. First, remove the denominator if there's any, then collect like terms, finally, divide by the coefficient of x. Once these steps become familiar, you'll find most linear inequalities very easy to solve. Now let's look at a question that's a little different. Example 4. 1 less than or equal to 3x minus 4 all over 2 less than 4. This is called a compound inequality because it has two inequality signs. Many students get confused when they see a question like this. But don't worry. Just follow the same process one step at a time. The first thing we need to do is remove the denominator. To do that, we multiply every term by the LCM. To find the LCM, think of the whole numbers as fractions. That is 1 over 1. 3x minus 4, all over 2. And 4 over 1. The denominators are 1, 2, and 1. Their LCM is 2. Now multiply through by the LCM, which is 2. We have 2 times 1 is 2. 2 will cancel 2, leaving us with 3x minus 4. 4 times 2 is 8. Now the inequality is linear. Since we have two inequality signs, we'll separate it into two simpler inequalities. The first one is 2 less than or equal to 3x minus 4. And the second one is 3x minus 4 less than 8. Let's solve the first one. Add 4 to both sides. We get 6 less than or equal to 3x. Now divide both sides by 3. We have 2 less than or equal to x. Now let's solve the second inequality. Add 4 to both sides. That gives us 3x less than 12. Divide both sides by 3. We have x less than 4. Now we combine both results. Our final answer is 2 less than or equal to x, and x is also less than 4. Let's graph it. Since 2 is included, we'll draw a closed circle at 2. Since 4 is not included, we'll draw an open circle at 4. Then join the 2 points with a straight line. In interval notation, the smallest value is 2. And it's included, so we use a square bracket. The largest value is 4. But it isn't included, so we use a parenthesis. Notice that after separating the compound inequality, we solved each part just the same way we solved the earlier examples. The only difference is that we combined the two answers at the end. Let's finish with one more example. -5 less than or equal to 2x minus 3 less than 7. This is another compound inequality. Since there are two inequality signs, we'll first separate them into two simpler inequalities. So we have -5 less than or equal to 2x minus 3 and 2x minus 3 less than 7. Let's solve the first one. Our goal is to get x on its own. Add 3 to both sides. We have -5 plus 3, which is -2. And here will be just 2x. Divide both sides by 2. We have -1 less than or equal to x. Now let's solve the second inequality. Add 3 to both sides. It will gives us 2x less than 10. Divide both sides by 2. We have x less than 5. Next, we combine the two solutions. Our final answer is -1 less than or equal to x less than 5. Let's represent it on the number line. Since -1 is included, we'll draw a closed circle at -1. Since 5 is not included, we'll draw an open circle at 5. Then join the 2 points with a straight line, to show that every value between them satisfies the inequality. Let's write the answer in interval notation. The smallest value is -1. And it is included. So we use a square bracket. The largest value is 5. But it is not included, so we use a parenthesis. If adding and subtracting integers is still giving you trouble, I've also explained it in a separate lesson. You can find the link in the description after this video. And that's how to solve linear inequalities, and represent the solution on a number line and in interval notation. Remember, once you understand the basic steps, every linear inequality becomes much easier to solve. If you enjoyed this lesson, don't forget to like the video and subscribe to Maths Masterclass for more mathematics lessons. Thanks for watching, and I'll see you in the next class.